Hi guys, earlier we learned that an operating system uses time sharing mechanism to switch between the programs and create an illusion of multiple CPUs. But for it to switch, first it needs to define what a running program is. And this definition is called process abstraction. A program in execution plus all the resources the OS assigns to manage and run it is called a process. This abstraction must allow the OS to run the program as if it has its own private machine without worrying about other programs or low-level hardware details. So let's break down what a process abstraction actually consists of. First is the virtual memory. This is where the code and the data of the process live. Virtual memory gives each process the illusion that it has large continuous private memory space even though multiple processes are actually sharing the same physical RAM. Inside the virtual memory, we have a code or a text segment where the compile instructions of the program are stored, and a stack, which is used for function calls storing local variables and return addresses, and a heap used for dynamic memory allocation at runtime, like with malloc or new. And the second one is the CPU state. While the process is running, the CPU uses small, fast memory cells called registers to hold temporary execution data so that it does not need to fetch everything from the RAM each time. The CPU state includes a program counter. It points to the next instruction to execute, a stack pointer. It points to the top of the stack, a frame pointer, which it marks the current function frame, and some general purpose registers which are used during the computation. This CPU state is what the OS saves and restores during the operations like context switching. And third one is the IO connections. A process also needs access to external resources like files, network, socket, or devices. The OS keeps track of these using structures like file descriptor table, which lists what the process currently has open or access to. And finally, every process has some management information like a unique process ID, ownership and permission details like which user created the process, scheduling priority of the process, executing state, etc. In summary, a process isn't just a code. It's a code plus virtual memory plus CPU state, IO resources tracking, and metadata. Now that we know what a process contains, the next step is to understand how the OS manages it over time. In our next part, we will understand two important concepts, what our process states and what a PCB is. Thanks for following along. See you in my next one.